Alrighty, let's get to the delicacies. Let's do slope intercept instead. Will be nice. Yep, just that. Go, go. You got the notes. You got the assignment. You got the book. It's all open. Get them. Now remember, this is just write the equation. You don't have to go graphing anything unless it helps you to do the process. Okay. He's here, Sally's here, Joe's here. He's here, Preston's out. And I thought I saw Pete. Yeah, there you go. What do you want? You need a different note packet for today. They're always in the back.
Right?
We have 5.6.
Wait. This one? Standard form. Did we finish this at all?
Oh yeah, all of that.
Probably wasn't.
5.5 was the day that I think I was gone. No, I was here for that one.
Yeah,
No, we did 5.5, and then last time we did 5.6.
So we're on 5.7.
Yeah, we're on 5.7 today. Okay, is anyone still rolling? You've got the notes. Write something in slope-intercept form that is what? Perpendicular. Perpendicular means my slopes are going to be opposite reciprocals. So if it was A over B, the one that I am going to use is negative B over A. Okay, I flop things. So I need to know what the slope of this guy is before I can even start. I don't see the slope right now. I'm going to have to do some work off to the side. So I'll start by taking 3x minus 2y is 6, and I'll get that y by his lonesome. I'll subtract 3x. I'll divide everything by negative 2. So the only thing in there that I care about is the slope. The rest of this doesn't even matter. If I want to be perpendicular to that line, 3/2 is perpendicular to what? Negative 2/3. Flip it and change sign. So I've got a slope to use. Huh. That happened. No. Apparently we had just enough that we were able to grab something off the other screen. I've got a slope and I've got a point. X, Y. So it would be a good idea to use point slope form. Y minus y1 is m times x minus x1. Plug in my y, plug in my m, plug in my x. Rewrite y plus 5 is negative 2/3 x minus 18. And I can't stop there because it tells me to write in, boom, slope-intercept form. By the way, there's still 2 water bottles up on the Misfit Toys shelf there. If any of you left your water bottle in here, there's an orange one and like a blue one. People keep leaving their water bottles in here. Okay, so just, if you're ever missing something, check that shelf up there. Okay, y plus 5 is, disturbert, negative 2/3 x, careful, know the ways of the fraction, or real good with calculator. What's negative 2/3 of negative 18? Positive 12, yep. And then subtract 5 over. So we have y is negative 2/3 x plus 7. That's the end of the rainbow. Okay. Our steps. Step 1. You would have had to rearrange this, unless you remember the negative b over a, or negative a over b thing. It's a little trick that you can do to go from standard to slope. You would have had to rearrange the original equation to find the slope. Did you use the actual perpendicular slope? Did you plug things into either point slope or slope intercept form? Is there anyone who went slope intercept form instead? Okay. Your side quest would have just been y is mx plus b. I know y. I know m. I know x. Negative 15 is negative 2 or negative 12. That's a 5, not a 15. There we go. Negative 12 plus b, add 12 to the other side, b is 7. But then you have to put the two together. Okay, now remember there were some of us that we really struggled with that, where we'd find our slope, we'd find our y-intercept, and we just quit. Make sure you actually put them together for the end. So whether you put your stuff into point slope or your stuff into slope intercept, you rearrange the equation, you find the right slope, you plugged stuff in, you did math to then get to the final answer. Okay, and when I say did math, that means, well, what happens if way back here you are exhausted and you wrote negative 15 instead of negative 5? Well, that's going to domino affect your answer. You get one off here, not one off here and here, if you can point to the exact error. What if you did point slope and you forgot minus a negative is actually positive? What if you just wrote y minus 5? Well, that changes things. Okay, so when I say at these different stages, it's did you do that part of the process and did you do it correctly? If you did that part of the process but did it incorrectly and the rest of the process still followed, that's the only point off. It's when we start doing this wrong and that wrong and that wrong. That's when we bring it down to 3 out of 5, 2 out of 5, stuff like that. And if you're there, remind, Spartan time, before school, after school, lunch. Okay. Unless we have a fire drill in the middle of one or a appointment or an entire family that's vomiting, whatever it may be, we might have to reschedule. So, I love just mowing on the Pop-Tarts. It's great. The homework. I forgot to do the login thing yet, so if you got homework, you're going to have to tell me what it is. Is there anything from the homie work that we need to go through? Yes, ma'am. 9. 9 probably has a just here's an equation, do stuff with it. Talk to me. What is it? One and the what?
That's a coordinate 1 and negative 3.
Oh, 1, negative 3. Okay. Okay. So we had a couple of problems where they would say, go through this point and be either parallel or perpendicular to this equation. What did they ask for this time? Parallel or perpendicular?
I don't think it was asking for either.
Oh. Someone got a book. 9, do the thing. Write an equation in slope-intercept form of line that passes through the given point and is parallel to the given equation. So the only thing that I care about in that equation is slope. If I'm parallel to 4, 4 is parallel to what? Check your definition. Parallel and perpendicular. 4. Parallel means same. Perpendicular means negative reciprocals. So they're just saying, this doesn't matter. The only thing that you cared about from 9 was use this slope, because you want them to be the same, and this point to go make an equation. Now, Matt, you're the one who's asking this. Do you prefer to put it in point slope form and rearrange, or put it into y equals mx plus b, and then, okay, so you prefer that and then put them together at the end? Okay, so you're the one asking, so we're going to do it your way. So I'd say y equals mx plus b. And I know a y, negative 3. Now I know my m. I know a b, or sorry, an x, to find the b. So I multiply. Negative 3 is 4 plus b. Subtract 4 to the other side and get b is negative 7. The catch is you have to put the pieces together at the end. If you know your slope and you know your y-intercept, you have to finish it by saying that. Okay, depends on what your jam is. My personal preference, the way that a lot of the books will do it nowadays, is point slope form. This is the way that we did it for eons. This is the way that I learned it in school, was to always do slope intercept form. Okay. You do whatever, which way you want, doesn't matter. You still got to the end of the rainbow. Others? Yes, ma'am. See, Dominic's just, he's got my back. Okay. 20. 20, negative 2/3, and now we got to be perpendicular. Okay.
What number is this?
20. And then it was 1/2 x plus who? Minus 1. Okay. And they want it to be perpendicular. So, same thing. What's your jam? Do you like doing the slope intercept and put it together, or point slope and rearrange? Okay. So we start with y equals mx plus b. Well, I have a y, I have an x, I need the m. And the m depends on whether they ask me to do parallel or perpendicular. They asked for perpendicular, so off to the side here I'm just going to say 1/2 is perpendicular to who? Okay, positive or negative? Remember, we flip and change the sign. That's what perpendicular does. So I'll flip it into a 2 and 1. I'll change the sign. Now, we're not going to leave it as 2/1. We're just going to write negative 2. But you have to get that slope. I recommend writing it off to the side. You don't have to. But if you do, it's one more thing that I can look at as I'm going through a problem, like, oh, on a test, to make sure that you know what you're doing. Multiply, subtract, 4 from both sides. And remember to put everything together at the end. I got a b, I got a m, y is negative 2x minus 1. Don't be afraid to use the arrows like that. Like, I've seen some kids, their assignments are all color-coded like this. I've seen other kids where they got arrows all over the place. Looks like Madden's football play from hell. It's great. You do what works for you to organize your thoughts. If the arrows help you to remember these two have to go together, do it. Okay. Utters? Yeah.
18.
Was 18 another one, or that was the parallel, perpendicular, or neither? Okay. So we had, all right, short-term memory deficits. Got hit in the head too many times. All right, so they're asking parallel, perpendicular, or neither. So I need to compare their slopes. I've already got slope number 1, 4. This guy, I don't have the slope yet because it's not in the right form. So I'm going to add x to both sides. X plus 0 is just x. Y is still not by his lonesome. Got to finish it off. What number is in front of that x? A 1, a little invisible 1. And sometimes we get kind of confuzzled when we see x on a numerator and nothing else. Like, it's supposed to be a coefficient in front of x. Why does it look like this? Because you need to take that x apart to write it as 1/4 x. So now I have my other slope. So I'm asking parallel, perpendicular, or neither. Parallel means they have to be the same. Nope. What is perpendicular again? Flip it and change a sign. It's neither. They're trying to get you. Sometimes they look really close, but not quite. Yes? Okay. Should be perpendicular to Main Street. Okay. So you got this little map, but the map is on a grid. And they say the park entrance is up here at 0,4. And I've got this line here of Main Street. Said we're going to have a new path and it's perpendicular to Main Street. That means I've got the point, I just need the slope. So we're going to have to count boxes on that thing. And there's no point even putting it up here because it would be all fuzzy. Can y'all see in the book? Like, you might have to kind of scribble your little triangle on it. Normally I'd say don't write in books, but we're probably never using these again, so whatever. The slope on it looks like it's up 2/1. Okay, because this whole thing is on a grid. There's a bunch of lines like this. Right? So you look at all of that. Really, you're going to make me get them all? Okay. You look at that and you see between these two intersections, it has a slope of 2/1. And I want to be perpendicular to that, so I'm going to flip it and change the signs. I have a point, I have a slope. We ran across this last time where I don't actually have to go through all the work right now. Because what is this point? Not just 0,4, but it's special. This is where it hits the y-axis. It's the y-intercept. They gave me the y-intercept. So if you had gone the entire full method, y minus y1 is mx minus x1. Then I would distribute, combine, add. Oh, hey, it was 4. That's weird. Or you did that y equals mx plus b version. You'd say, I know my y, I know my m, I know my x, and look at that, b is 4 again. That's because this point that they gave us was the y-intercept. So I don't actually need to do any of that work. I could have just counted boxes on my paper. I know the point, I know the slope, the point happens to be my y-intercept. Straight to answer. Doesn't always work out that way, but when it does, it's nice. Not always. But if they just gave me the y-intercept as my point, then I might as well use it. Well, that was about 2/3 of the assignment. I'm glad we're at least, that's your book, why am I going to try to take it? I'm glad we're at least asking now. Next stage is to also ask on Remind, is to also pop in during Spartan time, before school, after school. I said, you're white 4. There's nothing wrong with just staying after class for a couple of minutes and running through an extra problem or two. I'll have kids who just get a pass to come down here and they do their homework in here during Spartan time. That way they can ask questions as they arise as they're working. Good idea. Okay. I know my nerds get a little rowdy sometimes, but oh well. Especially if someone's doing tests, I'd tell them they need to pipe down. Okay. We've done scatter plots already. Maybe we didn't hear them called that, but do either of those vocabulary terms sound familiar? From middle school, do you remember hearing what a scatter plot is? Okay, kind of looks like buckshot hit the paper, right? Well, that's if there's no correlation. It should have kind of a trend to it. The dots are all headed upwards. The dots are all headed downwards. And that's what we're going to do, is we're going to plot all of our data points. Those are our dots, our coordinates. And then we're going to see, is there some sort of pattern to them? And we're going to make our own line, because one line ain't going to hit all of them. Okay. Some of you tried and do that on our nonlinear graphs from a few chapters ago. What happens when the points are like this? I'd have some kids who'd be like, no, that's algebra 2. Okay. Come back, we'll show you magic. No, what we're going to do is say, if those are the coordinates, then I'm going to make a line that shows me my general trend to it. Where I know it ain't perfect, but sometimes you use what you got. It's not the line of best fit. It's not the custom tailored suit. But it is the $79.99 special from the store in the mall. It's going to get the job done. Okay? I suppose, speaking of, suits and fancy attire, prom coming around, do they let freshmen go? I mean, I know you can't go yourselves, but do they let you go if someone asks you, an upperclassman? Yeah. Okay. A lot of schools, it's junior, seniors, and they can ask sophomores, but not freshmen. So I didn't know if that was a thing. Huh. All right. So the reason we need to know this is sometimes they're going to give us data, and the data kind of looks like a line, but it doesn't actually fit all on a line. So we just have to make something that's close enough. You know, teenagers, you know the words. Good enough. Right? That's what this is. We're going to make good enough. Because sometimes that's all you can do with your data. We have number of... Boy, this is an old book. Do any of you even own a CD? Like 4 of you? 5? Oh, okay. You're giving me... I would say giving me hope, but that just means that your parents are also old, and then I feel older. Never mind. Right? Table shows number of digital albums downloaded per year versus the number of CDs. Clearly, the CDs should not be that much more than digital download. God, this is an old book. What relationship exists between the two sets of data? So, what if I just ballparked it? That's all I want you to do. I want you to make a ballpark, just kind of graph. Just kind of chicken poke some dots. Like, this goes from almost nothing to almost 50. Goes 0 to 50. This goes from 767 down to 500 something. So go like 500 to 800. Just poke some dots in there. Okay, so this would be like the quick and dirty version of a scatter plot. And just tell me what relationship you see. If this goes up, that goes up. If this goes up, that goes down. What's the relationship between them? You know, the more time I spend around this friend, the worse my grades are. The less I sleep, the worse my test grade was. Okay, there's a relationship between X and Y. So just like a quick scatter plot and tell me. Oh, 800. Because the highest that we saw was 767. So this is a wing it graph, you know, it doesn't have to be nice. This has to be like the graphs that some of you do on your assignments when it says to graph it, and then you give me a BS graph that's not really the graph, and then I have to give you the 4 out of 5 or the 3 out of 5 for not actually doing it. Okay? But you actually are supposed to this time. Okay? Give me a ballpark graph, and then what is the relationship between them? Yeah. Right, that's exactly it. If, okay, I'm just going to wing it. Said, so like 4 something big, 13 something little smaller, 27 is about halfway there, 619, so about halfway there, 42 and change, almost at the bottom. This is not perfect. In fact, this is pretty ugly. If you did this on an assignment, we would count it wrong. But right now, we're just talking about, are you doing it? Can you tell me a relationship? If this is number of, what was it? These were downloads, and these were my CDs. Can you put that into words? What's happening? Like all the way back at the beginning of 4.1? Yeah.
As the years go by, the less people buy CDs, the more they download albums.
Okay. It's that relationship. As one is increasing or decreasing, the other increases or decreases. What I'd like you to write next to it is, isn't it always X's and Y's? Isn't it always inputs and outputs? So since my X's were downloads, those were getting bigger. So I would say as downloads increase, right, X does this. What does Y do? CDs decrease, right? They go down. Okay. And that's how we're going to say these relationships. Almost like when we first started talking about graphs at the very, very beginning of the semester. Remember, the first lesson was just, here's a graph, tell me what's happening. It's not enough to say, I can do basic algebraic manipulation, I can move numbers around, I can poke buttons on a calculator. You have to tell me what it means. Well, as x's got bigger, y's got smaller. Okay, now put it in context of the problem. As more people download music, less people are buying CDs. Should make sense. The actual CD album section at Walmart is like the size of this little table, and that's it. Because no one buys them anymore. So that's the general idea here is we're going to look at these scatter plots where we're going to plot points and it's going to do something. The something down at the bottom is going to be positive, negative, or no correlation. You've heard the word correlation before? The amount of sleep that you get correlates directly to how irritable you are the next day. Okay. Your grades at the quarter reporting period correlate to how willing my parents are to let me go to so-and-so's house. A correlation is a relationship between them. When I say that something has a positive correlation, I'm saying that, you might want to write this down next to it, as x increases, y's also increase. A negative correlation is as x's increase, my y's will decrease. Give me a real world example.
Yeah.
As this increases, so does that.
As your gallons increase,
Okay. As I fill my tank more full, the more gas I purchase, the more money I spend. Could I switch that around to be a negative correlation? As this goes up, that goes down. The money you have. I just filled my truck yesterday morning. It was like $89. Disgusting. Okay? Well, that's what happens when you have multiple global crises at once. Also, the current price on crude oil is right back where it was several weeks ago, like a month ago, but they're keeping the prices jacked up. That's companies. That has nothing to do with the actual price of gas. They're just keeping it that way. So, no correlation. That's when I can't tell what's happening. It literally looks like buckshot. It's just a bunch of dots. There is no relationship here at all. As x's get bigger, I don't know. Like, you can't even say anything. There is no relationship at all between x and y. That would be like if I said if I tried to find a correlation between your shoe size and your month of birth. Like, does being born in February somehow make your feet bigger? Like, there's no relationship between those at all. A correlation is just a relationship between them. If you want to look at some funny stuff over the weekend, you're just really bored and you're scrolling through TikTok for the 4th hour straight, look up false correlations or false correlation memes. People have gotten some really funny data and said that they match almost perfectly. like the number of Nicolas Cage movies to the number of death by suicide in Maine. Like, does that mean that the more movies Nicolas Cage makes, the more people want to not live? No. But the graphs were almost identical. There is a correlation there. Correlation does not mean causation. Just because it happened at the same time doesn't mean that this is what created that. That's what we're going to start getting into here, is talking about that relationship. What was the other one? It was like number of Canadian geese that landed on Lake of the Woods in Minnesota compared to the cost of truck tires. Like, you can actually put those graphs side by side and they're the same. It's hilarious.
We use like the line method.
And that's what we're about to do. Okay? A positive correlation, well, it should look like a positive slope. A negative correlation should look like a negative slope. No correlation should just be, I don't know, nothing. So, to make those, first we're just going to say, can you make the scatter plot? Can you tell me what's going on? So, I need to make an appropriate scale and axis again, all the way back to the beginning of the semester. Can you make an appropriate scale here? First of all, you identify X and Y, just like the beginning of the year. Can you tell me what your X and Y is? And then label those on your axes. It says, table shows altitude of an airplane and the temperature outside the plane. So, which one should depend on which? Does it get colder depending on the height? Or does the height depend on the temperature? Like, well, it's 40 degrees outside. Guess I gotta go higher. It's the other way around, right? The higher up you get, the colder it gets. Like, y'all heard of blue ice? The waste tank from the planes, the toilets. And sometimes if it doesn't just nicely spray out the way it's supposed to, kind of gets clogged on there. It makes this big blue, like disinfectant, water, and human waste chunk of ice, and then it'll fall off the plane. And it'll just crater someone's car. Yeah. There's another one to look up. Look up blue ice videos or airplane ice videos. It's hilarious. It's disgusting, but it's hilarious. Okay? This depends, this is what I can change, and this is what changes as a result. So down here I'm going to say altitude in meters. Up here I'm going to say temperature in degrees Fahrenheit. Remember, it's not enough to just say temp done. Temperature in what? Temperature in Celsius, temperature in Fahrenheit. Y'all in physical science, how about Kelvin? You've gone through that scale, right? Like 0 Kelvin is absolute zero and they haven't been able to replicate it yet. Because absolute zero is the 100% absence of all motion of all molecules. Nothing is moving. There is no heat of any kind and they cannot replicate it. They've come close, but they just can't quite get there. My scale needs to fit my data. So the altitude should go from what to what? 0 to 5,000. I've got 10 boxes. What should I go by? 500 sounds pretty good to me. So I'm going to put 0, 500, 1,000. Could I just go every other and say 2,000, 3,000, 4,000, 5? If I'm labeling every other, you can still tell what the scale is, right? We've run across that before. Or you can fill in the whole thing if you want. Next up, temperature. The highest it ever went was 61 and change. The lowest it ever went, almost 0. So, I guess I'm going from 0 up to at least 60. I got 10 boxes. Okay. I heard 10s, I saw 5s. Will 10 by 10, 100. That's enough, it'll fit. 10 by 5, 50. Not enough. Okay. Could I go by 6s? I'd have to go just a little bit off-road. 7s. But how many of us want to break up a box by 7s? That's tougher. So I like the idea of 10s. 10 sounds good. You could do 6s. You go right ahead. I'm going to do this. It doesn't mean you have to do the same thing as long as you're labeled. Okay, make a scatter plot of the data. Step 1, I put my variables and labels. Step 2, I label my scale. Step 3, poke a dot. Poke all your dots on there. You have to plot all of these points. So, 0, 59-ish. 500, 59.2. 1,000, 61.3. 1,500 is 55 and change. 2,000, 41.6. Okay, now we're going down. 2,500, 29.8, so just under 30. 3,000, 29.9, so about the same. 3,500, 18.1, so it dipped down again. 40,000, 26.2. About halfway through the box. 4,500, 12.4, and 5,000, almost nothing. For a while there, it looked like it was just a bunch of steps. But as I finished that last one and it was almost 0, now can you see that correlation to it? I could probably put my own line right smack through the middle of there. So I made the scatter plot. What type of relationship is it? I'm going to say that is a negative correlation. If we need to say that in words, which I recommend you right now so you get used to describing a context, as I go left to right, so altitude increases, my temperature is decreasing. As x's go up, y's go down. Curious what they're teaching you in physical science these days. Do you know why there seemed to be like a step here, and then it chilled for a while, and then kind of another step? Do you know why that is? Have you done in any of your science classes yet talk about the different layers of the atmosphere?
I was gonna say, are you going into different layers?
Yes, there are different layers and different densities to the atmosphere. Like, have you ever done one of those sand glasses with the different colored sands in it? Or maybe a suspension mixture? Leave your coffee or your hot cocoa sitting for too long and it gets that sludge at the bottom? Okay, that's the atmosphere. The light and fluffy stuff is going to be way out here. If there's less air, then there's less friction. If there's less friction, then there's less heat. The thicker in you get, think about the difference between a very thin blanket versus a very big, thick, poofy blanket. Wearing a light sweater and getting shoved outside in a fire drill, that's not really a fire drill, the middle school screwed up again, versus someone who actually has a thick jacket on. The thickness of it, the density of it makes it warmer. So every time you hit these new layers, it does that. I do have tape. Are we doing math or are we doing arts and crafts?
I am doing my graph, but I messed with my calculator, so I chose.
Okay. There's tape right there next to the calculators. So this was something that we did a while ago. We struggled a little bit with it, so we are going to practice it. I need you to make yourself a new scatter plot. If you need to talk to your neighbors to figure out what a reasonable scale is, do it. And I guarantee you, we aren't going to have the same graphs in here. Someone's going to have a different graph than you. And that's okay, so long as you're labeling it accordingly. Gallons bought. That does not go very big. If I try to make a graph that's only going by ones, this isn't going to make very much sense. Maybe I go by something else. Maybe I go by halves, tenths, by 1/5 of a gallon. I don't know. You choose. Crud.
Question. So they're comparing the population to the number of letters in the name. Like, how many people are in New York compared to there's 8 letters in the name?
Mm-hmm. That's what they're comparing. Number of chickens in Denmark compared to the number of Lego sets sold. Positive correlation, negative correlation, or nothing. Do those two things have anything to do with each other? No correlation. But there are some really fun ones. Like, number of weeks that Thelma and Louise was in the theaters correlates to the number of cars that drove into the Grand Canyon. That one would be causation, because that's how they died at the end of the movie. Oh, it goes to 13. Thought I could get away with going off road 1 for the 11. Went to 13. And as soon as one person starts snap, crackling, popping something, all of a sudden everyone just feels their joints. Now everyone's doing it, right? It's a little symphony of snap, crackle, and pop. Dollars spent with gallons bought. And you know what? Things repeat themselves. That's about $4 a gallon. Well, that's where we were at last week. I think it's just a little bit over right now, right? You know, things repeat themselves. Last time we had multiple global conflicts when we were right smack in the middle of Iraq and Afghanistan. I was in college. I remember paying for my old gas guzzler truck at that time that got like 10 miles of the gallon, 92 Silverado. I remember paying $4.50, $4.70 a gallon. Easy. Found out that my credit card had a $100 pump limit because you'd go in, you'd start filling it up, it hit 100, it shut the pump off. I'd have to hang it up and try again to put the next 20 bucks in. Okay? We've seen this before because this book is about 15 years old. There it is. So what's a scale? Aiden, what'd you do for the bottom? For dollars? Went by 0.5s? Do you, for dollars?
Oh, for dollars? Oh, no. Twos.
Twos. That should fit everything. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah, that'll fit it all. Okay. What about Killian? What'd you do for your gallons? That's extra tricky. Going from 1.1 up to 2.8.
Yeah, I couldn't think of one.
Okay. We can always do a subtract and divide method. Do 2.8 minus 1.1. How much is that? Okay. Well, I'm saying you want to look at the smallest and the largest because I have to fit that range. Okay. I have to go from 1.1 to 2.8. That's 1.7. And I have 10 boxes to do it in.
What if we just go off-road a bit and do 0.5s per box?
0.5s per box. Is anyone okay with going off-road? Like 1.5 boxes? It's, I mean, it would work. Anyone got a different one?
That's not the biggest.
Oh, there's a 3.3. Samsonite. Okay, we can't go to. Well, we can if we start at 1 instead of at 0. Okay. All right. Y'all remember how we jump up in the table or in the graph? How do I jump from 0 to 1? The little lightning bolt looking thing, right? So I'm gonna So I'm gonna do that, and we'll start at 1. You said by 0.5s. That'd be 1.52. Yeah, it'd be right about in the middle. Okay. I'm trying to use up the whole graph, but that works. 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5. Okay, that works. And then jam stuff in there. See, 10, 2.5, 11, 2.8, 9, 2.3, 10, 2.6, 13, 3.3, that's the one I just plain didn't even see it. 5, 1.3. 8, 2.2. Yeah. And 4, 1.1. Boy, howdy, does that look like a line? That looks very linear to me. And that line, like Dominic said, has a positive slope to it. So I'll say there is positive correlation. As money goes up, gallons increase. The more money you put into the pump, the more gas you get. Okay. Anyone here transfer from different state? Okay. Whereabouts? Oh yeah, that's right. Okay. Curious. I know Washington would do this. I don't know about Indiana. Y'all know around here, people are fairly trustworthy. If you say, okay, not trustworthy, we're more trusting, where I could go to a gas station and just say, pay cash, start pumping, knowing that I will go into the gas station and I will pay for it. Y'all, you get outside of the grain belt, that ain't the case. It's you pay me now. You go in the store and you put 20 bucks on pump 3. You go in the store and you give them your credit card. Or nowadays you just do it at the pump, right? But for a long time, I remember I would always just go get my gas. You get your gas, fill up. I could just drive away right now. That's what cameras are for. But you would pay ahead of time and then go into the store and you'd say, I have pump number 6. There's a couple of gas stations I know in Bell that still do this. Okay, the big D's, the Sinclair station, right on the main drag there. I fill up, I go in, I also get something that I probably shouldn't be eating, and I pay for them together. The positive correlation between the amount of money that I spent and the amount of gas I had, well, if you knew that you were going to be putting in about 5 gallons, you had to go in ahead of time and give them 20 bucks. And I think most of the places around Spearfish do that now. They say you got to pay first. Okay, the trend line, I already talked about it. The trend line is going to be our close enough best line. Now, there is such a thing as a line of best fit. Why is there a wallet here? I mean, they pay us in peanuts and insults. I'll take it. Okay, there's such a thing as a line of best fit, and we will not be doing it. Because in the calculator, you can get the perfect line. But since most of you don't even know how to make a fraction with our graphing calculators, I don't think going through our stat regression models in there is going to be the best idea. Instead, we're going to write down a few rules. Rule number 1. If I want a trend line, I'm going to make a trend line. I want a line that goes through 2 or more points. I need it to go through 2 or more points because I'm going to use 2 of them to make the line. The same way we've been doing. I've got points, I can make an equation from points. So I need to go through at least 2 in order to make the equation of my line. 3. Sorry, 2. I can count. What do you notice about both the lines that they made? Yeah, they go through at least 2 points. What's something else you could say? Okay, we are going to make our line through there. Through where? Am I going to make my line here? Am I going to make it here? not just following where the direction of the dots go, but I should have about, I'm going to say about because you can't do it perfectly, the same number of points on both sides. And 3, it needs to follow the general slope. Ish. Okay. So when we make a trend line, when we make a trend line, you might have a different equation than your neighbors. You might have picked 2 different points than your neighbors. And that's okay. In fact, if you look at the solutions for these, they do say student answers will vary. Example answer. So as we start doing these, you're going to have to compare with your neighbors and you're just going to be close enough. Some words that may or may not be new for you. Interpolation. This one we use a little bit less, but I'm hoping you've heard of the word extrapolation. I will extrapolate what comes next. The word you see in there is extra. Extrapolation, data outside my data point. Okay? Extra, more, outside. Interpolation is inside my data. Example would be you go back to that gas thing right above that. Interpolation would be, I'm going to ask you, how many gallons of gas did I get if I paid $2.75? Since $2.75 is in between the, what was it? Or $2.75 per gallon. Since that's between the 4 and the whatever we had, I already forgot. Anything inside, in between those data points, it's interpolation. I'm going to use a certain type of model. Extrapolation. You know what? I'll show you why this matters. Show you why this is going to keep coming back to us. If any of you have the graphing calculators, my graphing calculator in front of you, turn it on and hit graph. And you see what pre-calc was doing today. Okay? Which you also do in Algebra 2. They did models with interpolation and extrapolation where I might have different types of equations that I can use. And I have to pick one that fits best. Right now we're at the beginning of this journey where we're only going to do a line. But boy, are there a lot of other things that we can do. Okay? All of this is done on the calculator. We're not there yet. We're going to use what we know, and that's make this line that follows these 3 rules and do what you've been doing. Make a line from 2 points. So, make scatter plot, weight of a baby panda. Okay. Well, yeah, it's a baby panda. Approximate weight of a 7-month-old panda. So, the table goes through 12 months. Some of you are going to say, well, screw this. I'm just going to say 7 months is right in between here. Ballpark it. 31-ish. Okay, you just lost 7 points on the test. Good job, because you didn't do the rest of it. We have to go all the way through the process here. Step 1, you need to make your scatter plot. You label age in months, weight in pounds, get an appropriate scale. I got to go out through 12. I've got 10 boxes. What should I go by? You could. I don't want to fit all of those numbers to a 0.2 scale. If you want to go by 1.2, do it. Want to go by 1.5? Do it. I'm lazy. I'm going by 2s. Not lazy. Conservationist of effort. Okay. Weight. Need to go from almost nothing up through about 55 pounds. Got 10 boxes. 5s? 5 and you'd have to go a little bit off-road. I'll buy it. We didn't do it last time. We'll do it this time. It's very important that when you plot these points right now, don't just BS it, because you are going to be using these points to make your equation. All right, at 1, 2.5, right smack in the middle. 2, 7.6. 3, 12.5, right in the middle. 4, 17.1, almost the middle. 6, 24.3. 8, 37.9, about 3/5 of the way through. 10, 49.2, and 12 was off-road, almost a full box. I need to make a trend line. I hope you all have a straight edge with you, because you want to make a line that goes through at least 2 of those points. If it's not perfectly down the middle, if it's not right down the pipe, then you're going to try to make the same number of points on both sides. And it should follow this general slope. So here's what I mean. When I say follow the general slope, that is not a good choice. Like, well, there's points on both sides. It went through at least 2, but it doesn't follow the right trajectory. Okay? So you get your line. I'm going to try to draw a line that goes through these 3-ish and this one, but I don't know if I'll be able to do it. Actually ain't bad. Okay. Looks like I hit 4 points. There's 2 above, 2 below. That's pretty solid as far as a trend line goes. But I'm not done. Now, I need to move all of this stuff, so I got room to go make my equation. Make sure that's sitting good. There we go. Okay. So these coordinates, I can choose any of those 4 coordinates, any of those 4 points that I hit to make a line. I'm going to choose, you're going to have to read the table off for me. this one, and this one. Remember, I want that long barrel.
3 and 12.5 and 12 and 54.9.
Okay? How do I make an equation from 2 points? Been doing it for like a month now. Slope is y sub 2 minus y sub 1, x sub 2 minus x sub 1. And it's okay if you have to go to decimal land on these. Some of them might. What is 54.9 minus 12.5? Close. 0.4. Over 9. And that's not going to come out clean. Okay? 42.4 is not divisible by 9. So you're going to give me the ballpark of it. I'm going to say 42.4 divided by 9 is about this much. I want you to write down next to this. I don't care what the book says. I don't care what the directions say. On anything else, we are always going to go 3 decimal places. Always 3 decimal places. That comes from long experience of doing word problems with kids who couldn't handle fractions or expressions. And if I had them switch over to decimals in 3 places, they were still pretty close. As soon as you go back to 2 places, to the hundredths, things start getting a little sketchy. If you go to the tenths, it's trash. Especially the bigger these problems get. What happens when I'm finding the surface area of the Great Pyramids? Your hundredth off, because you rounded goofy, now translates to your answer is off by 500 square feet. Okay? 3 places. So I'm going to say that my slope is about 47, or was it 41? 4.71111. So we'll say about 4.711. All right. Your choice. Who wants to throw it in point slope and rearrange? Yeah. Who wants to go find B and plug them together? Okay. More people are saying that, so I'm going to do that. Which point do you want to use? Doesn't matter. I want to use these because I make an equation between these 2 lines, or these 2 points. I'm probably going to choose the one that's just smaller, easier to deal with. So we say y equals mx plus b. And I plug in there. I know y is 12.5. Now I know that m is about 4.711. I know that x was 3. Go find b. Times 3. 12 to 1, 14.133. Subtract. Get almost 12, 1.367.
1.633.
633. Oh, yeah, okay. Negative 1 point. Say it again. I already lost it.
633.
Okay. Smack them together. You got your slope, you got your intercept. I'm going to say y is about 4.711 x minus 1.633. Notice that I said about. I put the approximate symbol in there, not equals, because I rounded off that slope. Okay? Yes, sir?
Oh, I see what
Okay.
I'm
Now answer the question. I got the scatter plot. I got my line. What is the approximate weight of a 7-month-old panda based on my model? Where is 7 going? X or Y? X. It's my age, right? So, okay, you know how we just divided and it's got this long decimal train? That number is in your calculator. Does everyone know where the answer button is on your calculator? It's usually down here at the bottom in a second feature above a negative or a 0 or something. Does everyone see it? So I can now take answer times 7 minus that 16.333. Okay? See, your calculator's got this wonderful feature here where I can do stuff in the memory. I could have said 12.5 minus, what was it? That by 3? The group answer times 3. Okay, I could have these and now say mx plus b is, highlight it, times 7 plus that answer. And it's going to give me almost perfect. Okay. Now the reason that might be beneficial for me is sometimes, it won't always work, I might now be able to change that back into a fraction to have a perfect answer. Now, I wouldn't expect you to put that fraction on there. I would just say about 31.344 pounds. Point 3. Okay, I'm gonna plug my 7 in. This is the beginning of some pretty heavy-duty stuff that you're going to keep doing throughout math, where you need to make a model based on data. Math isn't just, I'm going to push numbers around, it's also telling me what it means. Okay? It's not enough to just push the numbers around. Now, on White 4 Friday with 4 minutes left, no, we don't have time for a second one. But that would be a good place for us to pick up on Tuesday. So, I'll cut it off there, and very honestly, I don't feel that we have enough information or practice to do this for our homework. But we do have a lot of old stuff that we need to practice. So you will have an assignment, it's just going to be practicing the stuff that we have been doing. Okay? But it will not be this. We will do more of this on Tuesday.